I apologize, I talked too much today. The lecture may go a little bit longer than usual, so I apologize. Let me speed up. So these small molecules, they're quite uncharged, but these two they're actually slightly charged, but that's okay because they are very small. Size matters. Small molecules, they can go through the cell membrane. The reason they can go through is because of concentration gradient. What does it mean? Usually, outside of the cell, we have higher concentration of this molecule. When outside of the cell, we have higher concentration of this molecule. Then it will go through, it will go to a lower concentration of inside the cell. It is an example of diffusion. We'll talk about diffusion in the later slides today. Concentration gradient. So usually more substances will be on one side of the membrane, but the other side of the membrane they will have less of the substances. It will establish something called concentration gradient because of the differences of the concentration on the opposite side of the membrane. So usually when we said going down the concentration gradient, going down meaning that it is the movement of the molecule of a substance or substance from an area of higher concentration to a lower concentration. We call this going down. And going down of a concentration gradient does not require any energy because it is like a natural physical property. And then we have something called going up a concentration gradient. Going up a concentration gradient, meaning that from an area of lower concentration to a higher concentration. Because we are going up a concentration gradient, it's like pushing something up to a hill. On a hill, we push something up on a hill. It's like a Greek mythology, pushing something up on a hill. Then it requires energy. And what is the energy that our body uses to push up the concentration gradient? We talked about this on Wednesday night. Do you remember the name of the energy molecule? Yes, it is the ATP. ATP, we talked about it here as well. Water. Okay, this is the trick question. I put this question for my physiology students. Actually, some of them they get it wrong. I make it a true or false question. So this is tricky. So just pay attention. Water is a polar molecule. Water is a polar molecule. Then how come it can go through the phospholipid bilayer? Because this is hydrophobic, right? How come water can go through the cell membrane? The reason is that we have something called aquaporin. Aquaporin, they are special channel. Remember membrane protein? One of them is called channel. So it allows water to go through the membrane actually in both directions, bidirectionally. And aquaporin is a special membrane channel that we can find in most of the majority of the cell. Let me tell you the question, the tricky question that I asked my physiology student. It's a true or false question. I asked them, water is a polar molecule that can go through the hydrophobic, the phospholipid bilayer that contains non-polar hydrophobic fatty acid chain. So when they read this statement, they can tell, okay, water on one hand is polar, on the other hand, the phospholipid bilayer contains the non-polar hydrophobic fatty acid chain. Then they will start to struggle. Well, on one hand, yeah, water cannot go through this membrane, but on the other hand, we all know that water can go in and out of the membrane. Then they will start to think, because they forgot about the aquaporin. Aquaporin, aqua means water. Porin is like a pore. Ring is like a protein. Basically, it's a protein that forms a pore to allow water to go in or out. So this is what we call aquaporin. large molecule ions or charged molecule, they are not able to freely go through the membrane. Large molecule, size matters. We already told you one example, which is glucose, cannot go through the cell membrane. Ions, they are charged. That's why they cannot go through the hydrophobic tails. And then charged molecule. Well, charged molecule. For example, phosphate group. Do we have the phosphate group here? No. Charged molecule, like phosphate group or what else? Well, like phosphate group, they cannot go through the membrane because they contain charge. Phosphate group here, yeah. Phosphate group, you can find dissolved phosphate group in the cytoplasm. They can move around like an ion, yeah, but it is a phosphate group in the cytoplasm. So channel protein, like aquaporin, they can form a pore in the membrane. Or the carrier protein, they can help the glucose to go through the cell membrane. The third way they can go through the cell is called vesicles, formed by endo and exocytosis. We'll talk about these two processes. So the large molecule, ion, and charged molecule, they can go through the cell membrane by three methods. One is by channel, like the aquaporin, or by this is basically telling you that the water goes through the aquaporin. And then a charged molecule, they cannot go through the cell membrane. Non-charged molecule, like the lipid hormone, they can go through the membrane. Macromolecule, like the glucose, they cannot go through the membrane. So we talk about diffusion. We briefly mentioned about diffusion. Now we go into a deeper detail. So we have diffusion. The direction is to lower concentration. That means it is going down the concentration gradient from a high concentration towards a lower concentration. It requires a concentration gradient. And example is a lipid soluble molecule and gases. Lipid soluble molecule like lipid hormone. And then facilitated transport. Facilitated transport is also from high to low concentration. We call it facilitated because it requires a protein. Protein like a channel or carrier protein. Some sugars such as glucose and amino acid as well. And then what requires energy? Active transport. Active transport, because I told you that it's like pushing up onto the hill. When you push something up to the hill, that means it is the movement of molecule from lower concentration towards the higher concentration. Of course, it requires energy. What is the energy that we use in our body? ATP. And then we can use active transport to transport all kinds of stuff. Basically, active transport takes care of everything else. Exocytosis, endocytosis, we'll talk about later. Exocytosis, meaning that exo means outside, cyto means cell. The last SIS is basically a process. That means it's the process that the cell push something outside. We call it exocytosis. So it is towards outside, from inside to go outside. Usually what happens is that inside the cell will form a vesicle that carry for example, you can carry the protein hormone or lipid hormone that we make inside the cell. And then the vesicle will be fused with the plasma membrane. When the vesicle fills with the plasma membrane, then the lipid hormone or protein hormone that was made inside the cell can be released to outside the cell. Usually the macromolecules, as I told you, lipid and protein hormone. This is how our brain and the pituitary glands secrete the hormone. We'll talk about exocytosis and the, how the entire process works. I believe we talked about this already in one of the online lectures. And then endocytosis. Endo means inside. So that means it's a process. Exocytosis is like a process. Cyto is like a cell. Endo means inside. That means it's a process of a cell that takes things inside. So the direction is from outside to the inside of the cell. Again, it is by vesicle formation, macromolecule. An example will be amoeba or white blood cell, we call it macrophages. Both amoeba or white blood cell macrophages, they will extend their so-called pseudopod or pseudopodia, pseudopods. They will engulf. For amoeba, engulf the food molecule. For white blood cell macrophages, they will engulf the foreign invader or the germs. Now we talk about diffusion. Diffusion, this is a definition of diffusion. It's a movement of molecules from an area of higher concentration to a lower concentration. This is a definition you need to memorize, unfortunately. But because once you memorize it, it is very useful. You'll see it again in physiology for sure. It is a downward concentration gradient because it is from high to low. It occurs until equilibrium is reached. What does it mean, equilibrium? That means it is same. The concentration become more or less the same. It gives you an example: a crystal dye put in the water, and then the water molecule will move, and the dye and the water molecule. That means the dye will disperse into the water. That means dissolve in the water until the entire water have a homogeneous color. And then we have to define solute and solvent here. Solute, most of the time in our bio-3 level, we can assume that it is a solid, like salt. Solvent, most of the time in our bio-3 level, you can assume that it is water. It's a liquid. An example will be water. So when you add salt into water, basically you add solute into solvent, then it forms solution. But if you take chemistry, your chemistry professor will tell you the scientifically correct definition, is meaning that solute and solvent, they are relative. It depends on the amount. For example, if you have a bowl, a beaker, a bowl of salt, but you add 1 drop of water into this beaker of salt, then the salt will be actually the solvent, but the solute will be the water. Yeah. It mainly depends on the relative amount of the substances. But for bio-3 level, just to simplify our life, just assume that solute, mainly they are solid, solvent, they are liquid. And as a matter of fact, you can assume that solvent is water. Because water is a universal solvent that we talked about in the previous lecture. So this is what we meant, diffusion. We drop a crystal dye in the water. At first, you will have a high concentration in the dye and low concentration in the water. But then diffusion occurs so that the dye molecules start to spread. And at the beginning, the spreading of the dye molecule is very fast. But at the end, or near the end, the spreading of the dye molecule will start to slow down. And the slowdown of the movement of the molecule will continue until it reaches something called equilibrium, meaning that all the dye will be evenly distributed into the water. So this is what it says in here. Another example of diffusion is gases in our lung. So this is our lung. Our lung is consists of this a small bubble. The small bubble we call it alveolus. It's a singular. Plural form is alveoli. So when these, they are basically one cell thick. This wall, the wall of the alveoli, they are actually one cell thick. Only one cell form this. We call it air sac. We call it air sac because it is where the gases exchange occur. Oxygen, when we breathe in air, then our lung will fill with oxygen gas, and then oxygen will be able to go through the one cell thick of the alveolus, and then you go into the capillary, that is surrounding the alveoli. So because of that, the oxygen gas only need to go through one to two layers of cell in order to go into our bloodstream. And it is also diffusion, because inside the alveolus we have high concentration of oxygen, but inside the blood vessels here we have relatively lower concentration. So the oxygen go into our blood by diffusion. Several factors that can affect the rate of diffusion. We'll talk about osmosis later, don't worry about it now. For diffusion, temperature affects diffusion. As we said in here, if we have a higher temperature, then the molecule can move faster. Well, because higher temperature will give the more energy to the molecule. Pressure. Pressure, for example, if we have a high atmospheric pressure, that means if we have a lot of air that is pressing down to us, then if we have a lot of air, then the diffusion of oxygen here will be faster because we have a lot of air. We have a lot of oxygen here pressing inside the alveoli. Then the oxygen will be pressed and then it will go into the blood vessel really, really quickly. Electrical current. Electrical current is very similar to temperature, but it's just that it energizes the molecule in a different way. It basically supplies a lot of energy to the molecule so that the molecule can move faster. It's very similar to the temperature. When the molecule can move faster, then they can diffuse faster. Molecular size, again, size matter. If it is a large molecule, it cannot move that fast, then the diffusion rate will be lower. If it is a small molecule, it can move faster, then the diffusion rate will be faster. Osmosis, let's talk about osmosis. The definition of osmosis here, it is a diffusion of water across differentially permeable membrane. Personally, I don't like this definition that much. The reason is that, firstly, it uses a different term, differentially permeable. As I mentioned, most of the textbooks, they said that they use either selectively permeable or semi-permeable. It's like the first time I see this definition, differentially permeable. And diffusion of water, it implies the definition. I would say the more concrete, better definition is the movement of water molecule. Movement of water from high concentration to low concentration across a selectively permeable membrane. Yes, water also have concentration. Whenever we talk about concentration, we mainly focus on the solute concentration. We seldom focus on the water concentration, but we in this case, osmosis is defined based on the water concentration. Let me ask you that, which one has a higher water concentration? A concentrated hydrochloric acid or a dilute hydrochloric acid? Which one has a higher water concentration? A concentrated hydrochloric acid or a dilute hydrochloric acid? The answer is the dilute hydrochloric acid will have a higher water concentration. So, diffusion occurs from high to low. That means from a more dilute solution to a more concentrated solution. Osmosis occurs the movement of osmosis is that the water molecule will move from a more dilute solution to a more concentrated solution. Because in a more dilute solution, we have more water there. The more concentrated solution, we have less water there. Osmotic pressure is the pressure that develops. Osmotic pressure, you can call it, basically it's like the concentration gradient. But it is the concentration gradient of water. Now, I like my definition better, it's simpler. Osmotic pressure is the concentration gradient of water. So the greater the osmotic pressure, the more likely the water to diffuse into that direction. It's telling me that if the differences between the two concentration of water is a lot, then the osmosis will start will be faster. Yeah, this is what it means. If the concentration between the two solutions of water is a lot, then the osmosis will occur really quickly. So this is an example. We used to have this demonstration in the Bio 3B lab, but last time I taught Bio 3B, we changed the Bio 3B lab. Somehow they stopped showing this because I guess not many students are interested to look at the demos, the demonstration. So what happened in here is that you have this, something like a glass container, and it has 10% of the solution. The red thing here is a semi-permeable membrane, but inside the beaker it is a 5% solution. So in the beaker, the solution is more dilute. Inside this green stuff here, it is more concentrated. So according to osmosis, the movement of the water molecule will go from the beaker into the green solution. That means from bottom to up in this direction. Water molecule will go in. So what will happen is that after a few hours, the level of this green solution will actually increase because we have more water solution to go into the this cylinder here. It will push the water level up, so that the solution, the final concentration of the solution in the beaker will be more than 5%, but the solution inside the cylinder will be less than 10%. So this is the visual demonstration of osmosis. You can actually see the movement of water molecule. We originally used this. We already have this as a demonstration in the Bio 3B lab. For osmosis, we need to talk about three terms that you need to memorize for sure. Isotonic, hypotonic, hypertonic. Iso means the same. Hypo means low. So one way to memorize it is that hypo, low. We have O in here, O in here. So it helps you to memorize. Hypo means low. Hyper, if hypo is low, then hyper means high. So what does it mean? Instead of just reading it out loud, I'll show you. I'll show you the next slides to explain this. I think looking at pictures is easier in this case. Of course, you can memorize the definition as well. But one thing I always like to emphasize to my students is that these three terms, you cannot use it with one solution. You have to use them always with two solutions, because one solution has always been like the reference. So in other words, these terms, they are relative terms. They are the terms to describe the relative concentration between two solutions. So I can give you an example now. How do we apply these two terms? So isotonic solution, meaning that the for example, you would put a cell, let's say a red blood cell, into solution. And if the red blood cell is in the, let's say, 0.9% NaCl solution, then it will be, this solution has the same, we call it tonicity. Tonicity, you can assume that it is like the concentration. You can assume that it's similar to the concentration. Tonicity. Because 0.9% sodium chloride has the same tonicity as the red blood cell, then the movement of water going in and going out of the cell will be the same. That's why I call it isotonic. One way you can say that is that, okay, 0.9% sodium chloride solution is isotonic relative to the cytoplasm of the red blood cell. In other words, take a guess. When, let me tell you my personal experience. My first food poisoning experience. What happened is that my first job fresh out of college was a lab technician. Yeah, I was a lab technician in UCSF, and then, as you know, San Francisco has a lot of Chinese restaurants. When I was working there, it was many years ago, so there was no so-called grading system from the government. That means the restaurant does not have the A, B, C, D grade. You do not see those signs. So basically, and there's no Yap, okay? There's no Yap. There is, I think, there may be Facebook in Harvard at that time, but it's not that popular among different schools yet. Anyway, there's no Yap. So we walk into a restaurant by faith, okay? Seriously, we don't know whether the restaurant is good or not, unless our friend recommended. So I walk into one of the Chinese restaurants and ate the chicken there. And after that, I believe it's the next day, I start to have diarrhea. And diarrhea is unstoppable. Meaning that I'm having literally, number one, from my ass, yes. I'm actually having water coming out from the back. It is unstoppable. And I just keep sitting on the toilet until a point that there's no liquid coming out. I still sit on the toilet as if something is coming out. I can feel the contraction of my bowel. They want to expel something, but there's nothing. I kind of know a little bit about the biology and stuff at that time, so I keep drinking Gatorade. But then, when I drink Gatorade, when after our body absorbs Gatorade, then it will either come out as liquid from my rear end, or I will just have a regular number one. But even my pee, my urine, they are very concentrated, dark yellow. So I know that I'm kind of dehydrated. So at that time I was in my early 20s. I was very young and strong. So even though I feel that I need to go to emergency room, I could still drive myself back to UCSF emergency room. And it was interesting because when I get to the emergency room, of course, what you see a lot of people lying down in the bed. They are whining as if they are extremely painful. They are very serious. But then I went to see the nurse. Of course, emergency room they are headed by nurses. So the nurse measured my blood pressure. After she measured my blood pressure, then she told me to stand up to measure my blood pressure again. As soon as I stand up, she immediately do this and asked me, "Do you want to faint?" I said, "Oh no." And then she measured my blood pressure when I was standing up. And then after that, she told me that, "Do you know that dehydration can kill?" I said, "Yeah, that's why I'm here. And that's why I'm drinking Gatorade." I was having a bottle of Gatorade with me. And then she told me, "Okay, let me take you to some place that will make you feel better." And she told me, she walked me across the emergency room, few of those people lying in the bed. They are whining as if they are very serious. And then she opened another door. Basically, after we go through that door, it is another room. I would say it is another emergency room that has no one there except one nurse sitting there doing nothing. Yes. Later on, I find out that in most hospitals they have two emergency rooms. One emergency room is for people to abuse. Let's say, oh, I have a paper cut. Oh, the bleeding does not stop, so they go to the emergency room. Oh, I have a fever. Oh, because I have a flu, so I go to the emergency room. So most of the people in the emergency room, they have no life-threatening situation. That's why the nurses, the doctors just put them there, let them sit there. And there's a real emergency room for life-threatening patients like me. So she took me there, and then the only attending nurse there who was doing nothing, now she has something to do. She basically connected me to IV saline. Take a guess, what's the concentration of IV saline? It's very obvious. Yes, 0.9% sodium chloride. 0.9% sodium chloride is the saline that we use in the hospital for people like me who have dehydration. So the nurse connect me with the saline, you know what to do, right? And then I was lying in the bed and then have saline. And then she told me this one thing, oh, if you want to go to pee, let me know. Okay, I'll just sit there. And then after the saline bag used up, then she changed another one. And after that, she changed another one. Because I was in the emergency room for so long, I started doing everything you can do. I look at the saline bag. Take a guess, what is the volume of the saline bag? How much saline is in the saline bag? In one saline bag? Take a guess. Each saline bag is 1 liter. Yes, it's 1 liter. And as you know, I also lay there and I do nothing. I just look at the dripping. Take a guess, how fast does it drip? I actually time how fast it drips. And it actually approximately 1 hertz. 1 hertz meaning that 1 drop, 1 second. And also take a guess, third guess, how much time does it take for the saline bag to use up, to finish up? So it takes approximately 1 hour, one bag. So it takes about 1 hour to finish using up the saline. That means 1 hour, 1 bag, and 1 liter. So every hour she come to change the saline bag, and then she change, I would say 3 saline bags. That means I stay in the emergency room for 3 hours. After 3 bags of saline, I ring the bell and tell the nurse, oh, I want to pee. And guess what her reaction? She said, wow, 3 bags of saline, now you want to pee. At that time, I didn't know what she meant. But then, later on, I find out that, take a guess, how much blood do we have in an adult human body? Take a guess, how much blood do we have in an adult human body? Let me give you a multiple choice to take a guess. Let's see, 3 liters of blood, 5 liters of blood, 7 liters of blood, 10 liters of blood. A, B, C, D, E. A, 3 liters of blood. B, 5 liters of blood. C, 7 liters of blood. D, 10 liters of blood. How much blood do we have in a normal adult body? The answer is 5 liters of blood. This is something that you should memorize if you want to be a healthcare professional. 5 liters of blood. In other words, they are giving me 3 liters of saline to rehydrate me. That means I lost so much water that my blood volume may be down to 2 liters or maybe a little bit more than 2 liters. So after 3 liters of saline, then they gave me, I want to pee. After I finished peeing, then they gave me another liter of saline. That means 4 liters, total 4 liters. After I finished the 4th saline bag, then the attending doctor came and talked to me. He's not attending actually, he's a resident. Because I can tell that he was extremely sleepy and exhausted. Yeah, only resident they are being tortured like this. But he maintained his mental functioning and talked to me in a courteous, friendly tone. And basically he told me, oh, you're fine now, you go home, you know, something like that. So, remember, 0.9% sodium chloride is, we call it physiological saline. Physiological saline meaning that it is isotonic to our body. If we have hypotonic solution, meaning that it is lower concentration than the cell. As I told you, it is relative terms. Then what will happen? When we put a cell in a hypotonic solution, let's say pure water, then the water will keep going into the cell because it is the lower concentration of water, this is a higher concentration of water here and lower concentration of water here. Or you can call it, we have a higher concentrated solute inside the cell, but lower concentration of solute outside the cell. So by osmosis, water will keep going into the cell, trying to dilute the cell. What will happen? The cell will gain water. We call cytolysis. Cyto means cell, lysis means breakdown. That means the cell will keep on gaining water until the cell bursts, until the cell break down. For red blood cell, we have a special term we call hemolysis. Hemo means blood, lysis means breakdown. So the red blood cell can suck in too much water until the red blood cell breaks down. On the other hand, if we put the cell into a hypertonic solution, meaning that the solution is highly concentrated, what will happen? The cell will start losing water. So the surrounding water, the hypertonic solution, will suck water out from the cell. When the water is being sucked out from the cell, then the cell will shrink. When the cell is shrink, we call this crenation. So this is what I told you on Wednesday. Someone said that what happened when we put salt on the meat to preserve the meat? It is because of this reaction. When we put salt into the meat, of course, meat can gain the salt flavor, but also it sucks up the solution in the cytoplasm of the meat, so that the cytoplasm of this meat, of the cell, they no longer have the optimal concentration to maintain the normal functioning. Because the cell, they lose a lot of water, something you may assume that it becomes dry up. When the cell is not in an optimal condition to function, what will happen is that bacteria cannot grow on the cell. And that's why we can preserve the meat. This is something that we talk about on Wednesday. Similar thing will happen to plant cell. For isotonic solution, there will be no gain or loss of the cell, so the cell will remain the same. If we put the cell into a hypotonic solution, that means we water a plant. We always like to say watering a plant. We are basically giving the cell hypotonic solution. The cell will gain water. However, you never see the plant cell burst. You never see a plant burst by giving it too much water. Why? The reason is that if you give them pure water, that means normally we're watering the plant, then what happens is that the cell will expand, just like what happened to an animal cell. But because the plant cell, they have the cell wall. Cell wall is like an armor that restricts the bursting of the cell membrane. Then the cell will not burst because the cell is expanding inside the cell wall. We call it the turgor pressure. Turgor pressure is the major reason that keeps the plant erect because all the water, all the pressure here is pushing against the cell wall. And then when you push against the cell wall, it gives the enough forces to help the plant to maintain straight. Hypertonic solution. Hypertonic solution, if we give the plant concentrated salt water, what will happen? Cell will lose water. We call it plasmolysis. Plasmo is like the plasma membrane. Lysis, breaking down again. What will happen is that the cell membrane, the cell will shrink, just like the animal cell or the red cell. Because the cell shrink, the cell membrane will detach from the cell wall. When the cell detaches from the cell wall, it looks like this. You will do exactly the same experiment in the Bio 3B later in this semester. You will put isotonic solution, 0.9% saline. You'll put pure water, and then you look at the plant cell, mainly the onion cell or Elodia cell, probably Elodia cell. I will look at it under the microscope, and then later on you put in a high concentrated salt saline solution. Concentrated saline solution, and then you will be able to see the plasmolysis under the microscope. So this is what you will do in the Bio 3B lab. So this is just a summary of both animal cell and plant cell. They go through similar process, but the end result is a little bit different. For animal cell, you will have the you have this cytolysis. For regular cell, we call it hemolysis. But for plant cell, it will actually generate a turgor pressure to support the plant to stand upright. For both animal and plant cell, animal cell we have something called prenation, shrinking of the cell. Plant cell we have something called plasmolysis. Plasmolysis is, you can assume that it is the detachment of the cell membrane from the cell wall. Detachment of the cell membrane from the cell wall because the entire plant cell shrink.